Welcome to Hypothesis Testing in Python. In this lesson, we will explore t-tests, chi-square tests, and ANOVA. We will use real datasets to learn how these methods work and when to use them. No prior experience is needed. Let us start our journey into statistical testing. Running the cell now. Get ready to apply these tools to real data, just like professional data scientists. What are hypothesis tests? Hypothesis tests help us decide if we see real differences between groups or just random chance. We often use these tests in science, business, and medicine to make decisions. Running the cell now. You will soon know how to test these real-world questions. Let us set up our Python environment. We will suppress warnings so that the notebook output is not cluttered. Now, import the main packages we will use. We bring in pandas for handling tables. NumPy is for efficient number work. SCIPy provides statistical tests. Seaborn gives us some real-life datasets. Matplotlib helps us visualize data. Running the cell now. Check that you did not see any error here. If something did not work, run this cell again or reinstall the package. Let us load our first dataset. We will use the tips data from Seaborn. This loads a dataset about restaurant bill tips. The shape shows us how many rows and columns there are. Head displays the first 5 rows of the data so you can preview what the data looks like. Running the cell now. Try describing what some of these columns might mean in your own words. Why do we use t-tests? A t-test checks if the average value from two groups is really different, or just by chance. For example, do people tip more on weekends? Running the cell now. Think of other real-life questions that compare group averages. Let us prepare a new column to tell if the tip was on a weekend or a weekday. Now, we label each day as weekend or weekday. We calculate the mean tip amount for weekends. We do the same for weekdays. Finally, we print out both averages to compare. This gives us the actual average tip on weekends. Here is the average tip for weekdays. Running the cell now. Take a look at the numbers. Do they look far apart to you? Let us run a t-test to check if weekend tips differ from weekday tips. We select just the weekend tip values. We also select the tips given during weekdays. Scipy's test_in function runs the test for 2 independent groups. We get 2 results. The t-statistic shows how different the groups are. The p-value shows the chance of seeing a difference this large if there were really no effect. This is the t-statistic. This is the p-value. Running the cell now. If the p-value is below 0.05, that means there is strong evidence for a real difference. Let us visualize the spread and averages of the 2 tip groups. This creates a box plot to quickly see group differences. We add a clear chart title. Label the y-axis to show that the numbers are tip amounts in dollars. Show the plot for you to see. Running the cell now. Notice the spread and if there are any visible outliers. What about more than 2 groups? To compare more than 2 groups, for example, tips on different days, we use ANOVA. ANOVA asks if there are any group means that are different from the others. Running the cell now. Can you think of a question that would need more than 2 groups? Let us test if the average tip differs between the different days. We will use ANOVA for this. We get the list of unique day names in our data. For each day, we build a list of the tip values. We now have one list for each day. The f_one-way function tests for differences across all groups at once. This prints the f-statistic, measuring how much the group means differ. This is the p-value telling us if this difference is likely to be real. Running the cell now. If this p-value is below 0.05, at least one group is probably truly different. Let us plot the data for all days to visualize the group differences. Use a colorful box plot to compare all 4 days. Give a helpful chart title. Label the y-axis for clarity. Display the plot. Running the cell now. Does any day look especially high or low? That can explain the ANOVA result. What is a chi-square test? A chi-square test checks if 2 categories are related or independent. Example, are men and women equally likely to tip above $3? Running the cell now. Think about other pairs of categories you could check. Now let us test if men and women tend to give more than $3 differently. Create a new column marking if the tip was above $3. Build a table that counts how often each group gave high or low tips. Run the chi-square test using this table of counts. Get the test statistic, p-value, degrees of freedom, and expected counts. This is the chi-square statistic showing how much the actual counts differ from what we would expect by chance. The p-value shows if this is a likely result if there were really no difference. See the actual count table. Running the cell now. If the p-value is below 0.05, that means that gender and large tips are related. Let us make a bar plot to see if one gender is more likely to tip above $3. We turn the counts into fractions for each gender. Plot only the true, above $3, rate as bars with color coding. Y label shows this is the fraction giving tips above 3. Add a clear title about what the chart means. Set the range from 0 to 1 for easy comparison. Display the chart. Running the cell now. Which group gives high tips more often? Can you think why? It is good practice to check how many samples we are using in each test. Print out the total number of tips records. See how many males and females there are in the sample. Running the cell now. Knowing the sample sizes helps us trust the test results. Handling missing data safely. Sometimes real data has missing values. Let us check and clean if needed for these tests. Running the cell now. Never trust results from data with a lot of missing values. Let us check for and remove any rows that could break our tests. This displays the count of missing values for each column. Remove only the rows with missing tips, day, or sex values. Print the remaining number of complete rows. Running the cell now. Now all our analyses will use only complete cases. Practice, t-test for smokers versus non-smokers. Try testing if smokers tip more than non-smokers. You can use stats.test_ind, just like before. Running the cell now. Pause and write your code now. Try to solve it before looking up the answer. Here is one way to do the t-test for smoker versus non-smoker. Separate the tip amounts for smokers. Do the same for non-smokers. Run the t-test for the two groups, making sure it does not assume equal variances. Print the average for smoker tips. Print the average for non-smoker tips. Show the t-statistic, which tells us how far apart the averages are compared to variation. Report the p-value to know if the difference is significant. Running the cell now. What do you notice about the averages and p-value? Take a minute to make your own guess about which group tips more. Now you get to make a prediction before seeing the answer. Type who you expect tips more and your reason. Show what you entered. Running the cell now. Making predictions is a great habit before running the tests. Extra, try ANOVA on lunch versus dinner tips by day. Can you run an ANOVA test but split by meal time? What story might the results tell for a restaurant owner? Running the cell now. Try split by day and time with Group B, then run stats.f_one way. Recap, what have we learned? You can now compare two group means with t-tests. Compare many groups with ANOVA. Test if two categories are related with chi-square. Check and handle missing data. These skills unlock many insights in real-world data. Running the cell now. Try asking your own questions with these methods. Keep practicing and subscribe for more tutorials. Try these exercises. Chi-square, is the day of the week related to smoking at tables? T-test, do people tip differently at lunch versus dinner? Enjoy your data adventure. Subscribe for more Python stats videos. Running the cell now. Let us keep learning together. See you in the next lesson.